So in this lesson, we're talking about composing functions. The word composing or composition has lots of different uses, like some of you music people might know about composing a piece of music, or you could have an art composition. The word compose literally just means to put together in whatever context you're talking about, and so in math, we can talk about composing functions, which means to put functions together. And not just adding or subtracting or multiplying them like we've done in the past, but actually taking one function and putting it inside the other function. So that's what composing functions means. Here's what that looks like. If you have f of g of x, this is an example of composing functions. It means literally take the function g of x and put it into the function f of x as its input. And we'll do some examples so you see what I mean. But the way this is typically written is like this. This is f composed with g. It's a little open circle. This does not mean multiply. It's an open circle, and it means to compose the functions. This and this are identical, so you can use one or the other. Basically what this means is you put the function g inside the function f, and you're always going to start on the inside. So as we work through these problems, keep that in mind. It's helpful to start on the inside and work out from there. For example, first of all, just a little review. Here's a function f and here's a function g. Let's find f of 5. So if I want to find f of 5, I would just take the function f, take out the x, and put in 5 as the new input. So 2 times a 5 plus 3. Take out the x, put in a 5, which is 13. All right. So now let's compose some functions. This says do g of f of -1, or g composed with f. So I'm going to rewrite that in this other format like this. So I'm going to do g of f of -1. I know that's a lot of parentheses going on, but again, we're going to start on the inside. Just do this first. Do f of -1. So let's do that. F of -1 is 2 times -1 plus 3, which is -2 plus 3, which is 1. So I found that f of -1, its output is a 1. So what I'm going to do is take that output and put it into the function g. Basically, I'm replacing this with a 1. I'm going to do g of 1. So now I'm going to take the output of that last function and use it as the input of the function g. So here's g, and I'm going to put in a 1. Whoops, I already have that. So I'm going to do 1 squared plus 5. 1 squared is just 1, plus 5 is 6. So that's my final answer. I put -1 into the function f and got out a 1, and then I put 1 into the function g and got out 6. So that's my final answer. Sometimes you're not going to put a number in. Sometimes you might just leave it as a variable. For example, on this one, we're going to do f of g of x. Again, I'll start on the inside and do g of x first. This is going to be very simple. I have g of x already. It's this. Like that literally is g of x. So what I'm going to do is take this and I'm going to put it in for g of x. Take that out, put this in its place. Now I'm going to put that into my function f. So this is a kind of long thing, but I'm going to put this in as my new input for f. So I'm taking out the x that was there, and I'm going to put in this. Basically what happened there is I took the function g and I just put it into x, or f. So here's the function g within the function f. It's kind of cool, actually. Then we'll distribute the 2, so 2x squared plus 10. Don't forget to add the 3. So my final answer is 2x squared. 10 plus 3 is 13. And there we go. We'll do a few more. On this one, I'm going to do f of g of negative 4. So f of g of negative 4. Again, I'll start on the inside and do g of negative 4 first. So let's find that. G of negative 4 would mean put in negative 4 right here. So 2 times negative 4, which is negative 8. I'm going to take that and put it in right here, because g of negative 4 we found is negative 8. So take that out and put in a negative 8. So now I'm finding f of negative 8. So I'll take my f function and plug in a negative 8. Notice my f function has 2 different spots for x, meaning the input needs to go 2 different places. So I'm going to write this out just without the x's. Negative 3 times the input squared plus 9 times the input. But I'm taking out x and I'm putting in negative 8. You will need parentheses because it's not minus 8, it's times a negative 8. Okay, now we'll need to simplify a bit. Do negative 8 exponents come first, so actually you could just type all of that in your calculator, but negative 8 squared is 64 times negative 3 is negative 192, and then so this is negative 72, but then when you do, if you do this, minus the 72, you get negative 264. So that's your final answer on that one. All right. On this one, again, this one just has x as its input. So I'm just going to do f of g of x. Basically what this means is take the function g of x and put it into f. Or if you want to think about it this way, start on the inside with g of x and go find it. That's this. So take 2x and put it here in its place. And now put 2x into f. So here's f. I need some space. Whoops. So negative 3 times the new input, 2x squared, plus 9 times the new input. And let's simplify a bit and see what we get here. Exponents still comes first, order of operations. Don't forget to do 2 squared. 2 squared is 4, x squared is x squared. All of that is times negative 3. And negative 3 times 4 is negative 12. Over here we've got 9 times 2, so 18 times x. All right, for this last one, notice it's pretty similar to what we just did. Instead of f of g of x, I'm doing g of f of x. Basically what I'm going to do is take the f function and put it into g. I'm curious, do you guys think that you're going to get the same thing? Because when you add functions, you do. When you multiply functions, you do. Both of those are commutative. So do you think that function composition, is a commutative property? Let's see. So let's try this. Sorry, I'm running out of room. Let's do g of f of x. Meaning I'm going to take the function f and put it into g, basically. Let's go find function f. It's this. And I'm going to replace this with what it actually is. So now I'm doing g of negative 3x squared plus 9x. That is a very large input, but it's okay. So now this is my new input, and I'm going to put it into the function g. G says do 2 times the input. So do 2 times the input. There's my input. And let's see what we get. So I'll need to distribute the 2 and get negative 6x squared. And 2 times 9 is 18x. All right, so did we get the same thing? It's pretty close, but it's actually not the same, this and this. So function composition is not commutative. Doing f of g of x is not the same as doing g of f of x.